Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to two-dimensional motion, that is motion in a plane, and one of the most important concepts associated with two-dimensional motion is the phenomena of projectile motion. Okay, so the next series of videos will be on this because it's a very important concept. So first, what is projectile motion? So anything which is thrown high into the air, it follows a certain path, and that path, it has a certain shape, and the only factor which influence, actually it's not one factor, there are two factors involved. Two factors which influence the motion of that object in the air, they are: first, the initial velocity with which the object is thrown into the air, the initial velocity, and that is the first factor. And the second factor is gravity, g-force, acceleration due to gravity. These two factors, they determine what will be the path followed by the projectile and everything associated with its motion, that is initial velocity, final velocity, velocity at any particular instant in the path, acceleration in the horizontal and vertical direction, horizontal range, total vertical distance covered, everything comes in that, and everything depends on these two parameters. So the basic definition of projectile motion is it can refer to any object which is once after being thrown into the air with some initial velocity, afterwards moves under the influence of gravity alone, only gravity, acceleration due to gravity, and it does not have any other force or agent which contributes to its motion, whether it's any engine or fuel, anything, nothing like that. Only gravity. Initial velocity, it is thrown with some initial velocity and then it moves under the influence of gravity. Let's say we have a small kid who throws a ball high into the air. So initially he throws the ball with some initial velocity, this initial velocity, he throws the ball. Then the ball moves in this way, this path, which is in the shape of a parabola, curved path, and here acceleration due to gravity is acting downwards. So acceleration due to gravity acting downwards and initial projection velocity, they determine what is the pathway which is followed by the ball, and finally it hits the ground. So here a lot of things are there which we'll be discussing in the next series of videos. So here there are a lot of things which come into play. For example, the total horizontal distance covered by the ball, the horizontal distance covered by the ball, then the height, the maximum height reached by the ball, then the velocity with which it hits the ground. So a lot of factors are there and other things which we'll discuss. Let's say the time taken for the ball to reach the maximum height, then the time taken for the ball after it's projected to hit the ground, that everything will be there. So here what you have to understand is that there are a lot of assumptions which are taken while we consider the motion of the projectile. First, air resistance is considered negligible, no effect of air resistance. Actually it is there, but here for simplicity we are neglecting air resistance. The effect due to the curvature of the earth, the curved nature of the earth, that is also neglected. And the effect due to rotation of the earth, that is also neglected. And we all know that acceleration due to gravity at different points, it is slightly different, but here we are considering it uniform, that is 9.8 meter per second square, everywhere it is constant. So these are some of the assumptions which we'll be using in our analysis of projectile motion. So some of the examples of projectile motion, this is the first basic example: a ball thrown into the air, a stone thrown into the air, or let's say we have a package which is dropped high from an aeroplane which is in motion with some horizontal velocity like this. Then a javelin thrower who throws the javelin, which will take a similar path. Then water flowing from a hose pipe, all the water molecules, they are following the projectile motion. So here in projectile motion, as two-dimensional motion is involved, why? See, here the motion of the ball is happening in two dimensions. First, the ball is covering certain horizontal distance, which is along the x-axis. That is clear from here. Also, the ball, it reaches a certain height, maximum height, which is along the y-axis, and then finally it drops down to the ground. So the net vertical displacement is 0, but it undergoes some vertical motion during the course of the projectile motion. So here the basic equations of motion, they are taken into consideration, which is v is equal to u plus at, which is final velocity is equal to initial velocity plus product of acceleration and time. S is equal to ut plus half at square. S is the displacement, u is initial velocity, t time, a is acceleration, and v square minus u square is equal to 2a, where a is acceleration, s is displacement, u is initial, v is final velocity. So here you see I have written the same equation with x and y subscripts. Okay, why? Because this equation, they are applicable for one-dimensional motion, where motion is happening only along one axis. So there is no need to specify whether it's x, y, z, whatever. Simply we are writing the equation. But these two equations, they are applicable for two-dimensional motion. Okay, this is for motion along the x-axis, this is for motion along the y-axis. Okay, so this is another important concept associated with projectile motion, which is the principle of physical independence of motion. What it basically means is that here, as the ball moves from its initial position, this is the initial position, to final position F, motion is happening along two directions. First along x-axis, this, let me use a different ink. Okay, there is happening along x-axis, and also motion is happening along the y-axis. Okay, so these two are treated separately. Okay, these two are treated separately. For example, see here the initial velocity of projection, it is something like this. It is projected like this, making some angle with the horizontal, let's say it's theta. This is the initial velocity. So it is a vector, both magnitude and direction is coming into the whole thing. So what we do, is that we resolve it into horizontal and vertical components. The horizontal component acting along the x-axis, that is u cos theta, and the vertical component is u sin theta. So here the initial velocity along the x-axis, that is called as u subscript x, and the initial velocity along the y-axis, which is the vertical component, that is equal to u sin theta. This x component will be used for the analysis of everything on the x-axis, and the y component will be used for analysis of every aspect of motion around y-axis using these equations. See, Vx is equal to ux plus axt. This is for x-axis. Same, final velocity along x-axis, initial velocity along x-axis, acceleration along x-axis, time. Time has no component. Time is, it's going on. It has no, it is not a vector, isn't it? Similarly, Vy is equal to Uy plus Ayt, the respective things along the y-axis, the components along the y-axis. We all know acceleration is also a vector, so acceleration can also be resolved into horizontal and vertical components. Same, S is equal to Ut plus half At square. So here you see the horizontal distance covered by this object, that is Sx. Okay, Sx, which is the horizontal displacement of the object, that is Sx. This is the horizontal distance, Sx. Now if you see the net vertical displacement at the final point, that is 0, because vertically it has covered no displacement. It started from the ground, it reached the ground. So the vertical displacement at the final point is 0. But if we consider this point, at this point the vertical displacement is maximum, equal to the height, the maximum height which the ball it reached during the course of the projectile motion. But at this point it is 0. Again, if we say at this point the height above the ground, that is equal to, let's say, h dash. So here the vertical displacement Sy, that is equal to h dash. So displacement is a vector, so that is also resolved into horizontal and vertical components. Velocity is a vector, that is also resolved into horizontal and vertical components, and acceleration is also a vector, so that will also be resolved into horizontal and vertical components, Ax, Ay. Okay, now here acceleration. If you see acceleration due to gravity, it is acting downwards. Okay, it is acting downwards, so it is acting along the y-axis. So Ay is equal to G. Okay, Ay is equal to G. Here I have always told you that when motion, that is the velocity and acceleration, they are in the same direction, acceleration is taken as positive. And when motion, that is velocity and acceleration, they are in the opposite direction, acceleration is negative. So here during the upward motion of the ball, with the u sin theta component acting upwards, okay, the u sin theta component acting upwards during the upward motion up until this point. Let's say this is point 1, this is point 2, and this is point 3. From point 1 to point 2, motion, the component of motion in the y direction, it is upwards, okay, u sin theta, okay, this. And gravity, that is acceleration due to gravity, is acting downwards. So in this case, during the upward motion of the ball from point 1 to point 2, gravity will be taken negative, minus g. But from point 2 to point 3, during the downward motion of the ball, downward motion of the object, whatever it is, downward motion of the projectile, when the component is acting downwards, u sin theta or v sin theta, it's not u sin theta, it's v sin theta, okay, v sin theta, because after it reaches this position, the vertical component becomes 0 at this point, only the horizontal component is there. Okay, we'll discuss more about this. Here I'm just giving you a brief introduction so that you have basic idea before we go into the detailed analysis. So at this point, the vertical component is 0, only we have the horizontal component ux, which is equal to u cos theta, which remains constant. So at this point, the vertical component or the y component of initial velocity becomes 0, and from here it undergoes the downward motion. So in this case, from point 2 to point 3, motion is downwards, gravity is also acting downwards. So gravity becomes positive. Okay, so these things are clear. So here you have to apply the 3 equations of motion separately. Okay, x with x, y with y. Okay, similarly v square minus u square 2x, here is a vx square minus ux square is equal to 2ax sx, and vy square minus uy square, that is equal to 2ay sy. So a, s, v, u, everything with these are vectors, they are resolved into their horizontal and vertical components. Okay, and they are treated separately. The motion along the x, the parameters of the motion along the x-axis, they do not affect the parameters of motion along the y-axis. Similarly, the parameters of motion along the y-axis, they do not affect the motion along the x-axis. For example, acceleration due to gravity, it does not play any role in the horizontal motion of the object. Okay, let me make it clear again using a new slide. Acceleration due to gravity, which is acting downwards, it does not play any role in the horizontal motion of the object, because it cannot accelerate or decelerate the motion of the object, because it is acting in the y-axis. Motion is along the x-axis. Okay, so if there is an acceleration component, let's say in this direction, which is opposing the motion, it will stop, it will retard, it will decrease the velocity or the motion of the object. If it is in this direction, then it will increase or support or accelerate the motion of the object. Similarly, let's say we have a ball which is thrown upwards. Gravity is acting downwards. So it will oppose the motion of the object. The ball will rise to a certain height, and then the velocity will become 0, and then it will start to drop. And while it is dropping, acceleration due to gravity is also acting downwards, so it will support, it will aid the motion, it will increase its velocity, it will accelerate it. So when the ball and the acceleration due to gravity, they are in the opposite direction. Ball moving upwards, gravity acting downwards, g is negative. When they are in the same direction, g is positive. Here in this case, motion of the object and acceleration, they are in the same direction, so acceleration is positive. Here in this case, acceleration and the motion, they are in the opposite direction, so it is negative. Okay, so these things are clear. Now in the next series of videos, we'll be discussing the different types of analysis of projectile motion with different cases. Okay, so for now you just remember the basic definition of projectile motion and this important concept, which is the principle of physical independence of motion. Okay, the motion of the projectile is a combination of two independent motions, motion along the horizontal direction, that is x-axis, and motion along the vertical direction, which is y-axis, and these two are independent of each other. There is no dependence, okay, independent of each other, treated separately, analyzed separately, every parameter separate from each other. One does not affect the other, okay, one does not affect the other, okay, this. So this is the basic introduction to projectile motion. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.